the 2 marks. Then let's go to the next question. What's the difference between element and compounds? So you guys, you have to know what is the definition of elements as I explained, and what's the definition for compounds. So I'm just highlighting what is most likely to be, but this definition thing, I'm not going to go through them. Why? Because I want to minimize the time. So what is an element and what's a compound? But compounds are made up of elements. You understand? But elements are not made up of compounds. Basically, compounds are bigger than elements. For example, if you have sodium, is an element. Oxygen is an element. But if I have sodium and oxygen, when I combine them together, yes, you form sodium oxide. So sodium oxide becomes a compound. So you guys, at least when they bring the example, you must know. So don't just cram the definition, but you have to know how to apply. Okay, classify. Anyway, this is symbol. Classify element, compound, homogeneous, and heterogeneous. Tell us what is smoke, is salt. The only thing which I can talk about here is this salt. Salt is sodium chloride, meaning that when I say sodium, salt, is it a compound? Is it a mixture? Is a compound which is made up of sodium and chloride. Smoke. Smoke is a mixture. Smoke is a what? Is a mixture. But is smoke the same color? No. It has different particles, meaning that it is heterogeneous mixture. What about oxygen? Oxygen gas. They are not saying oxygen atom, oxygen gas. So if they are saying oxygen gas, this is a pure element, pure compound. Yes, meaning that is a molecule, yes, but is made up of one thing. You understand? What about wine? Wine is made up of different things. Water, sugar, so it has different, I think even alcohol, yes, because it makes you to get drunk after certain time too. Certain time tea, and that's why there's some wines they say non-alcoholic wine, but when you look at it, it has the same, it's uniform, therefore it becomes uniform mixture. So you have to know, guys, how to differentiate these mixtures. Define heterogeneous mixture. So we have talked about it, meaning that the mixture which is not uniform. You understand? So guys, go and do these definitions. I'm not going to waste too much time on the definitions. Metals and non-metals have specific properties that makes it possible to use them for specific. These are properties of metals. You know, when I was discussing before, I think now name the property that is applicable for the following. Okay, and following examples and uses. Metals are used for electric conduct, wiring. Wiring. What is that? Wiring. When it means that it can conduct. It can conduct what? Electricity. Yes. And then metals are used to for steel frame in huge building, meaning that it can resist this one. It can resist what? It can resist the pressure. And then metals are used for wiring of fences. It means that they can be modified into small wires. So when you are such questions, you need to know what is called ductile, you need to know what is called malleable, you need to know what is called brittleness. You understand? When you say ductile, it means that it can be modified into small wires. Yes. When you say malleable, it can be modified into other shapes. You understand? When you say brittle, it means that it can break easily. So, guys, please go when you know. But you don't just say brittle before you have identified what causes it to be brittle. So, make sure that you know that. Write down the chemical formula of the following compounds. I talked about this. I talked about this and I said that please make sure that you know how to write. But how do you write the symbols? It's simple. You don't need to cram. Don't cram anything. Just go. Lithium is a metal. Go to the periodic table. Lithium is in group 1. It's going to lose 1 electron. Therefore, you come here. You say lithium is written like that. But it's in group 1. Therefore, it's going to lose 1 electron. So it is positively charged. Bromide is in group 7. So you go to the periodic table. You find bromide here is in group 7. It's only remaining with 1 to form a group 8. So it means that I'm going to come here and I say bromide is like that. But it's only remaining with 1 electron, meaning that it's negatively charged. Meaning that these ones, they cancel. So it means that there is nothing I'm going to cross. So lithium bromide is done. Magnesium is in group 2. Go to group 2, you'll find magnesium. Where's magnesium? Is here. So it means that magnesium is going to lose 2 electrons. It becomes positively charged. Is it clear? And then hydroxide is a radical. Anyway, this is a radical. You're supposed to know them. So it's negatively charged. It's like that. Guys, hydroxide is not like that. The negative is not on hydrogen. The negative is on oxygen. Because hydrogen is only having 1 electron. So it has already bonded with oxygen. Oxygen is supposed to have 2 bonds. But the second bond, that's why the negative is there. Hence, it's like that. So it means that the negative and the positive, they cancel, the 2 goes there. This 2 is going to govern the whole structure. Why? Because it is 1 species. Therefore, magnesium, yes, hydroxide. You put a 2 like that. So, iron 3 carbonate. Carbonate is like that. It's also a radical, but iron is in 3, group 3. Iron, it can be, these are transition metals, meaning that they don't have fixed state. It can be iron 2, can be iron 3. So it has lost 3. So it means that this is going to come here. Let me show you. Iron 3. Iron 3. And then carbonate. Carbonate is negative 2. Meaning that this positive and negative, they're going to cancel. Then this one is going to come here. And then this one is going to go there. And then you form iron. Yes. This 2 is down. And then carbonate. Then this 3 is going to be governing the whole carbonate. And then, sorry, it's 3. Because it's, and then when you find something like this, you'll find the people saying that, no, this is iron 2. No, this is not iron 2. This figure comes from here. So it's iron 3 carbonate. Iron 2 is written as like that. Why? Because it's 2 here and 2 here. So they cancel. Therefore, I remain with iron 2 carbonate like that. But this one is iron 3 carbonate. Then we go to the next question. The next question is give the name of the following compounds. How do we name this? Go to the periodic table, find this. So this is sodium. This is nitrogen and oxide. But the oxide, there are 2. So it's going to become sodium nitrogen dioxide. But we don't read it as like that. So sodium, don't forget that this is we don't read it like that. Don't forget that this is 3, we call it a nitrate. And then this one, we read it as a nitrite. When you have, like saying sulfate, and then you have sulfite. You understand? So this is called nitrite. If it is short of oxygen, is nitrite. Therefore, we don't read it as sodium nitrogen dioxide. No, as most of you say it. This is sodium nitrite. Sodium nitride. Why? Because the radical which is being added, please guys, first find out whether that is a radical or it's not a radical. And then this one, because this is a molecule, then it's gonna be sulfur trioxide. Doesn't have any charge. Yes, so it becomes sulfur trioxide. And then this is copper. Now look at this. Yes, look at this. Someone is gonna say that this is copper. How do you read this? Let me check. Yes. How do you read this? You're gonna find out that someone is saying that this is copper 2. No, this is not copper 2 sulfate. This, remember, sulfate is like this, and the copper is like that or like that. Positive 1. So this is copper 2, this is copper 1. So how do I form this? If it was like this and like this, these are going to cancel, and then I'm going to end up having copper sulfate like that. But now I have a 2. It means that it was copper 1 and then a sulfate. So it brings that here, goes there, this negative and positive cancel, and then I end up having a 2 here. That's why. So this is copper 1 sulfate. Hey, I think I should have a... You guys, as I said, that we're going to be having classes after this specifically for physical science, life science, maths, grade 10, grade 11, grade 12. But grade 12, yes, but now grade 10 and grade 11, we are here for you now. So that we can help you, we build you from grade 10, you go to grade 11, you go to grade 12. By the time you reach grade 12, you are good. So Thundereduc will help you to build for your distinction. Don't forget to like, share, and comment. Yes. Subscribe so that you don't miss out for our daily new videos. Every day we post, we teach you every single day, and we will continue teaching you. Anyway, let's go to that graph. Guys, we like this graph. Please know how to interpret it. The same way I've explained to you. That now this is a graph in a reverse way, meaning that this, in actual sense, this is a cooling curve. Oh, they have talked about it here. Is a cooling curve. It was the one which is the heating curve, then it would have looked that way up. You understand? Yes. So because this is a cooling curve, yes, so it comes from, it is a gas, yes. Now this is a gas, and then here it starts to cool. Now this is a what? A solid, and then now it starts to cool. You understand? Yes. So here the temperature is not changing, but here the temperature is changing. So when there is a change in the phase, yes, so this one becomes freezing, and then this one, what happens here? Yes. So if it is freezing, it means that it is not losing anything. And then when it's condensing, it does not lose anything, meaning that it's changing from the gas to a liquid. So let's go to the question. At which phase is chlorine at 38 degrees C? 38. So which phase is here? Which phase? So this is it. Remember, this is a cooling curve. So it means that this is a solid. It is solid what? Solid state. They say at 38 minutes here, solid state. Here, remember now, it's changing of phase. It's changing from liquid to, but now once it reaches here, it has reached the what? The solid. So meaning that's a solid. What is the melting point of chlorine? The melting point of chlorine, you go to the temperature. So this is the melting point of chlorine. Then they are saying that which phase, you guys, you must know how to answer this question. Which phase occurs between 0 and 9? 0 and 9. Which phase is this? This is a gaseous phase. Yes. So that's the phase which is happening there. And then they're saying that which phase change occurs between 26 and 28. 26 and 28. 26 and, yeah, which change, what is happening here? This is freezing. It's starting to freeze from liquid to a solid. Explain why the temperature remains constant at 26 and 36. Because there is change in the phase. Yeah, meaning that the temperature is the same. Now there is a change in the what? In the phase. Whenever there is a change in the, it's the same thing. Change in the state, the temperature is always the same. Then they are saying that, as I explained, then they are saying that, explain why temperature remains, okay. Energy is released as chlorine gas chlorine changes phase. Explain how the following properties of chlorine between 26 and 38 change. Space between the particles. What is happening here? Space between the particles. When there is change in the phase, the space, they start to become what? Become smaller. Yes. And then movement of the particles. Movement of the particles. What is happening with the movement of the particles? The speed at which they are moving reduces. Yes. And then strength of the bond between the particles. The strength is also now increasing. That's why now the temperature is not being lost, but this is actually what happens. The space reduces, the movement reduces, and then now the strength between the bond also increases. Why? Because it's changing from one phase to another. Remember, the more compact it is, the more the stronger the bonds. Define boiling point. So it's the point at which okay, that's the definition. Just go and then define those definitions. What kind of change that takes place as chlorine cools down? Physical or chemical? When you are cooling, there is nothing chemical here in this. There is nothing. When talk about heating curve, cooling curve, there is nothing, I repeat, there is nothing chemical there. It's always physical. Why? Because it is reversible. You can cool it, you can heat it. So it is reversible. So there is no big deal there. Then they are saying that compare the table below. Do not redraw. Okay, sharp. Write down the energy of Bohr diagram or below the box diagram for sulfur. Where is sulfur? Oh, here they are not saying anything. There is no sulfur here. So you go to the periodic table and you look for sulfur. Look for that element. So the element is having 16. So it means that you're gonna come here and then you start drawing. You're drawing, you draw. Yes, using this. So meaning that the first one is gonna be 2. So it's 16, So it's 2, so it's now 14. There's gonna be 2. It's gonna be now how many? 12. It's gonna be 2. Another. This is gonna be 6. So it's gonna be 6 now. It's gonna be 2. So it's gonna be 4. So it's gonna be 4 here, meaning that it is in period 3 group. Period 3. Yes. Group 4. Let's go and find out. Did I say? Yeah. Period is. Where am I? Yeah. Let me see. Oh, this is 3. Nah? So you add the same shells. So it's 2 is 4 plus these 2. So meaning that is 2, 4 plus 2. So it means that it's going to be in group 6. Period. This means period. This means the period, the same period you add those periods. Period 3, and then the number of electrons in the orbital, that last shell, then it gives you. So it means that it's period 3, group 4. So when you are writing, you start with this, you go to this, you go to this, you go to this, then you go to this. So that then you are able to write. So that's it. Yes, group 6, and then period 1, 2, 3. Yeah, correct. So now we go to the next question. Magnesium is in group 2, né? But now is 12. So, but now you're not going to write 12. Why? Because of this positive charge, which means that it has lost 2 electrons. So it means that instead of 12, it's going to be 10. When you're writing, then it means that you must write 10. Study the electron configuration okay, of the following. All right. Oh, here we are supposed to answer questions here. Okay. Don't forget number of protons. Don't forget that atomic mass is equal to number of protons plus number of neutrons. And the number of protons for an ion, I say that protons are more than electrons for a negatively charged, and protons are less than electrons for positively charged. Let's go. Okay, now this one is this. Okay, mercury, phosphorus, 15. So what? But this is having 3. So electrons, neutrons is gonna be 15. 15, because neutrons cannot be, is not exactly the same as protons. But okay, electrons is gonna be number of protons, yes, is equal to number of neutrons. But this one has a positive 3, meaning that 15, because of the negative, it means that it has gained 3 electrons plus 3. So the answer here is gonna be 18, meaning that the answer here is gonna be 18. You understand? And then now you go to this one. It has lost 2. So this one and this must be the same, but now it has lost 2. So it's gonna be 10, because of the positive means lost. What about this mercury? Go to the periodic table, then you'll find the actual numbers. So you just come to the periodic table, look for mercury, then you'll find the numbers which you are supposed to put there, because they didn't put any conditions. Then they go to the next question. Study the electron configuration of the substance. Identify substance A. What is substance A? You can find substance A. How? 3, period 3. Now it means that I know that this is in period 3. But it has 2 electrons plus 1, because it's 3, 3. Ne? So it means that it is 3 plus 1, which gives me 4. It means that I will find it in group 4, period 3. Let's go. Group 4, 1, 2, 3, 4. Period 3, 1, 2, 3. But group 4. So the answer is silicon. Then I go to B, but B is a negative charge. Oh, we said. Okay, so here is gonna be group the period 2, but which group? 2 plus 6. 2 plus 6 gives me 8. So period 2, group 8. I go to period 2, 1, 2. Yes, so it's gonna be neon. Yes, so that's how we identify those things. They're saying that what is the valence? How many valence electrons does A has? Meaning that how many electrons are supposed to are involved in the bonding of A. Bonding of A. We say that yes, we say that A is silicon. Okay? Yes, is silicon. So if you feel like you can't get it, ne? You can't get it. This is what you can do. You use what you call the octet rule. So you say 2, 8, that's 10, 6. So meaning that, you see, it is in group 6, meaning that the valence electrons, they are going to be 6. And then its valence, if you look at its valence, yes, its valence, the valence, where is it? Is it B or A? Its valence is 6, né? And then the valence electron is going to be 8. Yes. How? By calculating here. 2 plus 6, 2 plus 6 gives me 8. So the valence electron is 8, while the valence is 6. Then we are saying that lithium is found in nature too, okay? This one and this. And then they're saying the abundance. Guys, make sure that you know how to calculate the isotopes. Explain what is isotope. That's a definition, meaning that what is, oh, this is explaining. But it's the same thing, it's a definition. Atoms with the same number of protons, but different number of neutrons. Yes, meaning that elements, they have the same number of protons, but different neutrons. So it means that the atomic mass is different. So in this case, calculate the relative atomic mass of this. So here you're gonna say the percentage, which is 92.5 divided by 100 times they say that this one is what? Lithium 7, yes, plus oh, they're saying the balance, the rest is this. So meaning that that's what's the balance. You have to subtract using a calculator, and then you say that it is 9. It's 100 minus 92.5. Actually, yes, divided by 100 times 6, because they said it's 6. So when you add, when you get the answer here and you get the answer here, the answer you get will be the mass of the relative mass of lithium. Calculate the first and the second ionization energy and explain. Calcium has the first ionization energy, this, and the second ionization energy, this. The third ionization energy is this. Explain why the third ionization energy is much more. Guys, when the first ionization energy is this and the second ionization energy is this, while the third one is extremely high. Why? Because don't forget that calcium is in group 2, meaning that it loses these 2 electrons. Once it loses these 2 electrons, what happens? It means that it has become stable. It's valence electrons, the electrons here, the calcium, where are you? Here, it has become stable. If you I use a octet rule, you can understand, because it is 20, so it's gonna be 2, 8, 8, 2. So now it has lost these 2 electrons. So now it means that it has become 2, 8, 8. You understand? I'm using this so that you understand it better. But it's the same thing even if you use Aufbauer principle. So this is 2. You see now it is stable. It acts as an inert gas or inert gas. So now what happens here? It means that calcium here, what is going to happen here is when you remove one, you're going to have to require a lot of energy because it's already stable. You cannot remove any other electron unless you have enough energy. That's why the third electron is having to remove it. You have required to double or triple the amount of energy you have been using. So why? Because it had obtained the stable state. So to remove one electron more, then you require high amount of energy. Question 6, which kind of bond between the atoms exists? Okay, covalent. Now you need to know which covalent, which is ionic, which is metallic. Metallic between metals. I showed you the Z line. Yes, that from here, like this, like this, like this, like this, like that. So these ones, metals, non-metals. Sorry. So this is a metal, a non-metal. So what is it? Think it is, that one is clear. Ionic. This one is non-metal, covalent by sharing. This is metal only, that is metallic. This is boron, and chloride, which is ionic. So it's not ionic, it's not beryllium, it's boron. Boron is a non-metal. However much it is a metalloid, but it is regarded as a non-metal. Check is there. So that's the answer. So this is covalent, metallic, covalent, ionic. So you have to know which one is a non-metal, which one is a metal, so that you are able to get the answer there. Lithium is ignited. Ignited means it's burnt to react with oxygen gas to form in air to form lithium oxide. It is this a chemical or physical? Because you are burning in the air, that becomes a chemical change. A chemical. It's not boiling. Burning. It's a chemical change. Give a reason. The reaction is irreversible. Yeah. Balanced equation. Lithium plus oxygen. You get, guys, I know that lithium oxide, because lithium is group 1. So it means that you put a 2 here, and then now if you put a 2 here, I think it is, you put a 2 here, now it becomes 4. So you put a 4 there. So now it's balanced. Solid, gas, solid. Don't forget to write the states, because states are very, 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 very important in the equation. Then they're saying that provide the law of conservation of mass is adhered. Prove that the law of conservation of is adhered. So in this case, you're gonna have here lithium, therefore this side, and then the other side, lithium is 2 times 2, lithium is also 4, and then here oxygen here, oxygen is 2, and then here oxygen is this times this, so oxygen this side is 2, meaning that neither matter is created nor is destroyed, but can be changed from one form to another. That's the law of conservation of matter or mass. This is a bonus. This one is for a bonus. So bonus is not that much, but I'm going to upload this. So you have this question. I've given you some questions concerning about this. So it's for you to practice. Please don't go without practicing them. What is boiling point? We have been talking about it. Which apparatus? How does the wire goes on top of the apparatus assist in heating process? Don't forget that wire goes. It tries to spread the heat equally. So then they are saying that, you see, number of protons, number of neutrons. You have to know that protons plus protons and electrons are always the same in atoms, but if it is positively charged, you will add electrons. No, you will lose electrons of that charge. If it's calcium, you lose 2 electrons. If it is chloride, you gain this charge, which is 1 electron. Yes, actually it's there. Aluminium. So you need to know that. Neutrons, go to the periodic table. You can find the neutrons there. But if you can't find them, still you can know you have the mass. They have given you the mass, whereby protons plus neutrons is equal to atomic mass. So you know the number of protons. You don't know the number of neutrons, but you know the atomic mass. Therefore, you're able to find the neutrons. So it's simple. Calculate relative atomic mass of this. Here it is simple. Calculate the value of x, because this is percentage. So you have to say 90 plus 0.27 plus x is equal to 100. And then you find the x. Then after that, 90 to calculate for this, 90 divided by 100 times the mass, which is 20, plus you go to this one, divide by 100 times 21. You go to this one, divide by 100 times this. The answer you get will be the answer for that. So don't forget that this is a bonus. Then ionization energy. Explain why the first ionization energy generally increases from sodium to this is the same period, meaning that if it's the same period, sodium to this, to argon, you see, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chloride, argon. So it means that why is it ionization energy increases? Is because of the decrease in the atomic radius. I explained that because of the same shell, we keep on adding the same electrons, so the attraction from the nucleus increases. So for you to remove one electron, you require high amount of energy. That's why you have this increase in the ionization energy. I think that's the bonus. That's the bonus. What about this? Draw the Lewis diagram. Lewis diagram. Guys, don't go without knowing how to draw a Lewis diagram. Please. Define covalent bond is the definition. Make sure that you know how to define it. Lewis diagram of oxygen. Guys, oxygen is like this. So it means that this is, don't forget that this is formed by sharing. It means that I'm going to have oxygen 1, 2, 3, 4, 5, 6. So it's 6. Then another oxygen this side, 1, 2, 1, 2, 3, 4, 5, 6. So it means that this one and this, they're gonna form a bond, and this one and this, they're gonna form a bond. So meaning that you just bring them together, so that don't forget that oxygen is like this. So meaning that they're gonna form a bond there and a bond there, and 2 lone pairs on these oxygens. So and then they're saying Lewis diagram of ammonia. Ammonia is formed like this. This is ammonia, meaning that hydrogen is 1. Nitrogen, find the group number, is 1, 2, 3, 4, 5. So the remaining one is gonna be hydrogen. Hydrogen. You see? So basically that is a simple diagram, meaning that this one becomes a bond, this one becomes a bond, this one becomes a bond. Yes. However much it's forming trigonal pyramidal. Yes. Anyway, they're not asking for the shape. They're saying that what is the valence of sulfur? So I think now we know very well what is the valence of sulfur. Then count the number of electrons which are involved in bonding for sulfur. Meaning that the valence of sulfur is going to be what? How many electrons are involved in bonding? How many electrons remaining for sulfur? Check. You can come here and see that sulfur is here, so it's 1 is 2, meaning that its valence is gonna be 2. Why? It's because of the 2 electrons which are involved in the bonding. Define they are saying that sodium chloride is a crystal. That's okay. Draw the structure of an arrangement of ions in the sodium. The cations. Cation is, remember, is a positively charged. You know how to draw the structure of sodium. I showed you there. Just for the case of time, draw the dotted diagram of sodium chloride, and also I did this one. So cation means a positively charged ion. Anion means a negatively charged ion, and then ion is a charged particle. It can be, remember, cation, anion, and then ion. Charged particle, negatively charged, positively charged. So you must know that. I think that is it. This marks the beginning of the end of our discussion. Please go through this paper. Go through this paper. You are not going to regret. You are not going to regret. Make sure that you go through this paper. Yeah. And I've said that don't forget to like, subscribe, and share. After your junior exams, based on the requests I've been receiving, we're going to start classes for physical science. Please keep in touch, subscribe so that you don't miss, and put the notification bell on so that when we post, you are able to get. Thank you very much. God bless you. M. Saidi, as usual.